Good morning students, myself Shraddha Agarwal from Holy Hearts Education Academy. Today I am going to deal class 12th topic, that is electrolytic cell, from the chapter electrochemistry. Now electrolytic cell are those cells which convert electrical energy into chemical energy. Now coming to the topic, if we are going to draw the diagram of electrolytic cell, it composed of a beaker, two rods which act as a anode as well as cathode. Anode is connected to the positive terminal of the battery, whereas cathode is connected to the negative terminal of the battery. Both the electrodes are dipped in a solution that is known to be electrolytes. And you know very well that electrolytes are salt solution. Now if we are going to take the example of a electrolysis process of copper, I am going to make a impure copper rod which is going to act as a anode, whereas pure copper strip will act as a cathode. Both the electrode are dipped in a copper sulfate solution which acts as a electrolyte. So during the cell reaction, we can see that here the pure copper ions decomposed from the anode and start depositing at the cathode. So after some time we will see that the cathode become thick, whereas anode start decomposing and it is going to be thin. Whereas the impurities which is left behind is collected here, which is known to be anode mud. And this anode mud is also very precious for us because it contains trace amount of precious metal like gold, silver, platinum, etc. Now if I am going to study about the working principle of the electrolytic cell, the first thing that we are going to keep in our mind is that anode is connected to the positive terminal of the battery, whereas cathode is connected to the negative terminal of the battery. First point. The second will be electrolyte dissociate into their respective ions, that is cations and anions. In third step, ions migrate toward the opposite plate. That is, as anode is a positive terminal, here anions, which are the negatively charged particle, migrate toward its. Cathode is a negative terminal rod, hence the cations, that is the positive charge ions, migrate towards it. Then the last will be ions lose or gain electron to neutralize itself. So at anode, oxidation take place. Oxidation means loss of electron. Now you can see that at anode, which ions have migrated towards the anode? Anions. Anions are negatively charged. That means it has already acquired the electrons. If it want to get neutralized, it has to lose electron. So as it is losing electron, the process is known to be oxidation, which is carried out at the anode. At cathode, reduction take place. That means gain of electron. Now you can see that at cathode, the cations comes toward it, and cations are positively charged species. That means they have already lose electron, and to neutralize itself, it has to gain electron. When they are going to gain electron, the process is known to be reduction. Reduction carry out at the cathode. Now if we are going to see the same example, that is the working principle of the electrolysis process at anode. Copper rod, that is impure copper rod, dissociate into copper ions by the losing 2 electron, whereas at cathode, reduction take place and this copper ions will gain an electron and gets converted into pure copper. As it converted into pure copper, start depositing at the cathode. So after some time the cathode become thick, whereas anode come to be thin. Now some important example of the electrolysis. First is the electrolysis of molten NaCl. The first step, NaCl dissociate into Na plus ion as well as Cl minus ion at anode. Just now I told you at anode oxidation take place, whereas as anode is a positive terminal rod, the negative ions migrate toward it. So the negative ions among this Na plus and Cl minus is Cl minus ion. So Cl minus ion migrate toward the anode, and after losing electron it gets converted into half Cl2. Why I have written half Cl2? Because chlorine is a diatomic gas. It is not a monoatomic, hence I have written half. Now, just to balance the equations, 2 chloride ions are there. So, 2 chloride ion will lose 2 electron and get converted into Cl2 gas. That means at anode, chlorine gas is released. Now, at cathode, sodium ions will gain 1 electron and get converted into sodium, whereas 2 sodium ions will gain 2 electron and get converted into 2 sodium. So this is the electrolysis process of molten NaCl, which is very simple because only NaCl is present. But when we are going to see the next example, that is electrolysis of aqueous NaCl. aqueous NaCl, that means apart from this NaCl, water is also present. So in first step, NaCl, which is going to decompose to form sodium ions as well as chloride ion. Second step, water decompose to form H plus ion as well as OH minus ion. So we can see here two positive ions are present as well as two negative ions are present. So at cathode, the reaction with higher value of electrode potential is preferred at cathode. Higher value of electrode potential. From where you are going to get the value of E naught? From the electrochemical series. So when I am going to write down the E naught value of sodium ions, it comes to minus 2.71 volt. Whereas E naught value of hydrogen come to be 0.0 volt. Among these, 0.0 volt is higher than that of minus 2.71 volt. Hence, at the cathode, hydrogen gas will be released. That means H plus ion will gain electron and get converted into half H2 in the gaseous form. That is, from the cathode, hydrogen gas will be released. So among sodium ion and hydrogen ion at cathode, hydrogen gas is going to be released. That means in preference, hydrogen ions will gain electron more easily than that of the sodium ions. Now, in the H plus ion is produced by the dissociation. Now, H plus ion is produced from where? This H plus ion is produced by the dissociation of water molecules. So we can write down the equation. Water molecule will gain one electron and get converted into half H2 plus hydroxyl ion. Now, at anode, the reaction with the lower value of E naught is preferred at the anode. The reaction with the lower E naught value. So, E naught value for the chloride ion come to be 1.36, whereas for the hydroxyl ion it come to be 1.23 volt. Hence, it is expected that hydroxyl ion should oxidize first as compared to the chloride ion. But actually it is not. Due to over potential of oxygen, liberation of chlorine gas is preferred at the anode. Why? Because of the over potential of oxygen. And student, this is the most important point. I think so 2 to 3 times this question have asked that during the electrolysis process of aqueous NaCl, which gas is released at anode. So remember that in general it should be oxygen, but chlorine gas is released at anode due to the over potential of oxygen. So when we are going to write down the cell reaction, chloride minus ion will lose one electron and get converted into half Cl2. When I am going to write down the overall cell reaction for aqueous NaCl, I will write it down NaCl plus water gets converted into sodium ions plus hydroxyl ion plus hydrogen gas as well as chlorine gas. So chlorine gas is liberated at anode, whereas hydrogen gas is liberated at cathode. Now these sodium ions and hydroxyl ion combine to form, you can see sodium ion combined with hydroxyl ion to form NaOH, that is aqueous form. In 10th class also you have learned this process, but not in such a detailed manner, and that process is known to be chlor-alkali process, because in this process you are going to get the chlorine gas, one of the alkali, that is sodium hydroxide, as well as hydrogen gas. This is about the electrolysis process of the molten as well as aqueous sodium chloride solution. Students, you are going to prepare the notes of this topic as well as solve NCERT question related to the electrolysis process. Thank you.